Hello, students. So what we saw is that dictionaries are a little like lists, but they're a generalization. We don't have to restrict ourselves to the keys 0, 1, 2, 3, and so on. But can we really do some of the fancy stuff that we can do with lists with dictionaries? And the answer is yes. What did we really try to do with lists? Well, we went straight to list comprehensions. We can do the exact same thing with dictionaries. So let's say we want a dictionary that goes, let's start simple. Let's say I want to go from, numbers to their squares. So 1 to 1, 2 to 4, 3 to 9, and 4 to 16. Let's stop there. Let's just do those numbers there. Let's try to do this as a dictionary comprehension. So how could we do that? Well, what I'm going to do is I'm going to say, hey, I have a value and a key. So we're going to take the values to be 0, 1, 2, 3, and 4 like we have there. So I'll say for I in range 5, that's going to give me 0, 1, 2, 3, and 4. And what do I want? I want I on the left, but on the right I want I squared. So what I'm going to do is I'm just going to write that. And let's see if that works. Absolutely. Worked beautifully. Okay. What if instead of going to the squares, I want the square roots? I want to go in the other direction. Well, now I want to skip some values. But for us, it's no harder than it was in order to get those squares. Because if I want to get the roots, what am I going to do? Well, I'm going to take the i's of 0, 1, 2, 3, and 4. Now those are going to be the values. They're on the right side of the colon here. And the keys are going to be the values of I squared. Let's see if that works. And absolutely it works. I get 0, 1, 4, 9, and 16 for the keys because I is just going through those numbers 0, 1, 2, 3, and 4, making these the keys on the left, the I squareds, and these the values here on the right. Okay, let's try more dictionary comprehensions. Let's say, what did we do with lists? We had, instead of iterating over one range, we had multiple variables. We could do the same type of thing. Let's say I wanted to have a bunch of tuples, and I want them to go to their sum. I just have to decide, how big I want this to be. So that's pretty big. But let's try this out. And this absolutely worked. Basically, I took a bunch of tuples where these numbers are allowed to be 0 through 4 in both slots, and each of these has to go to the sum of the values inside the tuple, which, as you see, it does nicely because 3 plus 4 is 7. This also shows that the keys don't have to be integers. There are some restrictions, basically the same types of restrictions that we have for sets, but we can still have lots of different options for our keys and whatever we want for our values. Let's try another example. Let's use the numbers 0 through 9. There are a lot of variants of Sudoku, and one variant of Sudoku, what it does is it has clues which tell us whether or not numbers are consecutive. So you don't have to play Sudoku to understand this, but you need to know that it uses the numbers 0 through 9, and basically whether or not numbers are consecutive or not. For instance, 2, what's consecutive to 2? Well, 1 and 3, right? Because 1 and 2 are consecutive numbers, and 2 and 3 are consecutive numbers. They're 1 apart. So let's say we want a dictionary that takes each number to the collection of consecutive numbers. So for 1, we would just have 2, but for 2, we would have 1 and 3. For 3, we would have 2 and 4, and so on and so forth. And we could stop there, but of course, we want to go through 9 because Sudoku uses the numbers 1 through 9. So let's try to do this as a dictionary comprehension. Well, one thing I could do is I could say, hey, let's go from I to the set of I plus 1, or let's do the minus first. And this might not give me exactly what I want, even if I put that 1 there, because Unfortunately, it included a 0 and a 10, which are not in Sudoku 1 through 9. So what's one way we could fix this issue? Well, there's actually a number of things we could do. One thing we could do is we could sort of say, okay, if we're outside the numbers 1 through 9, let's not include it. How do we do that? Well, we could use an intersection. And as you see, that's going to work, because now we're going to take the set of numbers consecutive to 1, but they also have to be in this set. And of course, we could even use a set comprehension for that. If I wanted to, I could say j for j in range 1 through 10. And that's an example of a set comprehension which sits inside this intersection, which is inside a dictionary comprehension. There's lots of different choices for the way we can deal with these things. But those are some nice examples of dictionary comprehensions using various things. Sometimes this one used tuples as the keys. This one used sets as the values. We can mix things up and get a lot of variety in our dictionary comprehensions as well. One thing is, you could think about this as each number goes to the numbers that it is consecutive to. And when I say goes to, that's also the same language that we use for functions, because we can often think about dictionaries as functions. This is a dictionary that sends numbers to the numbers consecutive to it within the space we're dealing with. So it's like a function that would send 4 to the set 3, 5. We could think of all of these as functions. This is a function too. It's a function that sends a tuple to the sum of the entries in that tuple. And I guess the first two here were very obvious functions. Squaring and square roots are famous functions. Now, of course, these are discrete functions. They're not going to be defined everywhere because they're only defined for the finitely many values that we put in the dictionary. But we can use them like functions if needed.